Hello everyone, thanks for joining the APN Digital Summit. We hope you've enjoyed the presentation so far. Before we get started with our presentation, we want to go over a few housekeeping items. First, this session is being recorded. We will send you the recording when the presentation is over, along with the additional information to help you continue learning more about these services. If you do have questions during the presentation, please add them to the question window. We will do our best to answer all the questions as they come in, but if we don't, we will follow up in an email after. If you're having any audio issues, try using your computer's mic and speakers. This usually fixes the problem. Thank you again for your time today. I am now going to pass it over to our presenter.
Hi everyone, welcome to the final session in today's serverless track, the serverless developer experience. My name is Mike Deck. I'm a partner solutions architect specializing in serverless. And yeah, during this session, wanted to spend some time focusing on how serverless impacts software developers. So we've got a lot of content out there. If you go to reInvent, if you look at our blog, if you look at a number of different resources out there, there's a lot of content about how to design architectures for the AWS serverless platform and best practices for how you build and deploy systems that way. But oftentimes we don't focus as much time talking about how this impacts software developers, the people that are actually writing code day to day. And so that I think is an important piece to kind of discuss about how this impacts our customers, who are actually building the software directly, and how you as partners can help contribute to that kind of experience and help teach developers best practices, as well as build the tooling that's going to have a positive impact on software developers who are moving into the serverless space. So to kind of kick things off, the first thing that I always like to talk about is kind of the console-based development pattern that I oftentimes see customers get started with. So I know that for me personally, the first Lambda function I ever wrote, I certainly used the console to develop it. I think that the vast majority of customers, typically their first exposure to writing Lambda functions is to open up the console, create a new function, maybe use something from the serverless app repo or a blueprint, but otherwise just kind of type in some code directly into the integrated IDE that's part of the Lambda console, run it and test it through that process. And it's really a fantastic way to kind of get your feet wet and get some experience building serverless applications that way. However, this is definitely not what we would recommend doing for kind of real production development. So once you really get into building real live applications based on Lambda, you definitely don't want to be using the console to develop the code itself. And surprisingly, I see a number of customers who kind of get down a path where they have real production code running in an AWS account. They're still using the console to kind of manage and edit that. And when you think about that, that's really pretty much the serverless equivalent of SSHing into one of your production servers, using VI to edit a file and then bouncing the service directly on that box. And while certainly I'm not going to claim that I've never done this, and I would imagine there are a number of you out there who probably have done this as well, whether you want to admit it or not. It's definitely not a best practice, and I think it's definitely something that we can all agree we should avoid doing if possible. And so, kind of looking at some of the limitations here and of this kind of initial developer environment that a lot of people use. The console has a lot of great features, but it's not really a fully featured IDE. It doesn't have any kind of capacity for doing local build automation or linting or installing additional plugins to run tests and do those kind of things locally. There's not really a good way to manage environments effectively in terms of having various test environments that you may want to deploy to, or how do you integrate and interact with other services that you need to test against. There's no good integration with version control, and collaboration becomes really challenging when you've got multiple developers on a team who are all trying to contribute to the same code base. definitely don't try to use the console when you've got that kind of situation, or you definitely can end up with issues. So given that the console is not the right way to do this, what does kind of a developer environment look like? So if we're going to do this the right way, what does that mean? Well, first of all, you need some kind of mechanism for you to kind of write and edit code. And the key takeaway here is that you should continue to use the IDE that you already know and love to do this. There's no reason to change out the integrated development environment that you're using to actually author application code today. So regardless of whether you're targeting a serverless or a server-based environment, the tools that you're using to actually author code really don't need to change. And our goal is to provide as rich an experience as possible, regardless of what IDE you're using to actually develop the code itself. Now, in addition to having an IDE that you can use to kind of manage that, you're also going to want to use standard source control approaches. So again, nothing really changes here. This is the standard model that you would use for managing any kind of professional development project, whether that be Git or another version control system that you've chosen. That's fine, but you should definitely be using source control of some sort. Now, one of the areas where things do start to change a little bit is in terms of having kind of test accounts and the ability to deploy your application into an environment where you can test it and see how it kind of plays in a production-like environment. And we'll talk a little bit more about this in a few minutes. But I think this is one of the areas where things do change a little bit in terms of how do we actually manage this from a serverless kind of perspective. And then the last piece is how do you test? And being able to run tests against those environments and manage kind of a holistic testing strategy for how we're going to test and debug our application is another important aspect that I think oftentimes trips customers up. So, overall, we're going to focus in this kind of talk on those last 2 points that I mentioned. So the deployment models and the ways to test code, because the overriding message, I guess, that I want to get across is that the rest of the sort of tooling, the rest of the developer experience is for the most part unchanged. You don't need to really think about like, oh, I need to go out and get a brand new IDE. I need to go out and get a new unit testing framework. Oh, I need to go out and change the way that I'm doing version control. All of those pieces of the puzzle really kind of continue to be the same, and really even going deeper than that, kind of the underlying best practices when it comes to designing and writing good, clean code still apply exactly the same way when you're building serverless applications as they always have. So let's take a look at deployments in particular. So when you take a look at, what does it take to deploy a serverless application to AWS Lambda? Well, there's a few different steps you need to go through. First of all, you have to build your code. So especially if you're using a compiled language, you'd have to actually go through a compilation step. Even if you're not compiling the code itself, you may be doing other kind of linting or static analysis or minification or other kind of steps in that process. Then you zip up the code into a zip archive that can actually be deployed to Lambda, upload that to S3. Then you can go and create a role that your function can assume within IAM. And then finally, you're going to actually create the function and then configure any event sources. Now, if we add into that, an API gateway, say we want to create a serverless API endpoint that's backed with an Amazon DynamoDB table, then there's even some additional steps that we've got to put in there in order to actually create the API and the resources and the methods, and then configure that database as well. And so, when it comes down to it, in order to get a relatively simple API up and running, there's actually a number of different steps that you need to go through. And when you're kind of clicking through it in the console, it's not so bad. But that's not really scalable. It's not repeatable. It's certainly not, again, this is kind of getting back to that console-based development that we talked about that we want to try and get away from. And so when you look at something like this, hopefully the first thing that you think of is, oh, well, we can automate that, right? We have tools for doing this. We're just creating AWS resources, and there's a lot of great resources out there for defining infrastructure as code. And at the end of the day, Lambda functions and API gateways can be defined using templating languages the same way that you do for your VPCs and EC2 instances. So let's take a look at what that would look like in a CloudFormation template. Now, because there are a number of different resources that we need to define in order to get all of these pieces together, our CloudFormation template ends up becoming pretty detailed. There's a lot of individual resources that are getting created here. This is, not intended for you to sort of read through and comprehend. It's really intended to kind of demonstrate that, even a simple application can end up getting somewhat unruly if you're using raw CloudFormation to manage it directly. And this becomes not so much an issue in the upfront development. I think that most people can probably write one of these templates in just a few minutes. It doesn't take too long to kind of copy and paste and update and get a template to the point where it's actually working and deployable. But long term, in terms of the maintainability of this and the ability for someone new to join your team and open this up on their first day of working on the new team and understand what's going on with it, I think can be a little challenging. So because of this kind of challenge that we've seen with customers who are developing serverless applications and having this problem with kind of these overly verbose templates, we've created a new application model called the AWS Serverless application model that actually that sits on top of CloudFormation and provides a more concise way of defining the components of your serverless app. So if we take a look at the same application that we've been talking about in a SAM template compared to the original CloudFormation template we looked at, you can see it's much simpler and more concise. Here we're able to kind of define at the top level a single serverless function resource, and then within that function define the HTTP endpoint, the API gateway endpoint, as an event source directly on the function resource itself. So now this single AWS serverless function resource type is actually under the covers defining multiple physical resources inside of our CloudFormation stack. And then similarly, there's a simple table concept that allows you to very easily define DynamoDB tables that you would typically use in these types of simple APIs as well. So basically, that's from a developer perspective, that's one of the big value propositions of SAM, is this ability now to simplify the definition of your serverless applications and make it much easier to kind of define the metadata and the structure of the application itself in one of these template files without having to be overly verbose as you would with a raw CloudFormation template. So to talk a little bit more about kind of the specifics of what SAM is, SAM really has two different kind of components that comprise the overall system. So the first is the SAM CLI, which is a local utility that you run on your development machine locally, as well as a CloudFormation transform. And so this is a component that actually runs inside of the CloudFormation service itself. So let's take a look at each of these. So the SAM CLI, one of its core functions in sort of the deployment process is to manage that kind of zip and upload process that we talked about previously. When you create a Lambda function, you're going to have to create a zip archive for every individual Lambda function, and that has to get uploaded to S3 before you can actually do the Lambda deployment directly. So what SAM allows you to do is in the template that you maintain, you simply point to a local path within your source code repository where your code lives, or potentially if you have a compiled output artifact, then you would be pointing to that compiled artifact in your target directory. But you don't have to worry about kind of zipping it up or where that code is going to live in S3, simply point to the local directory, and then when you run the SAM package command, the SAM CLI is responsible for doing the zip, uploading it to S3. It will only do that upload if things have changed within an individual function, and so and then it'll orchestrate that across all of the different functions that are defined within your template. So if you have multiple Lambda functions defined in a single template, then you'll be able to, then SAM will take care of kind of managing the deployment of all of those. And then it'll update the template. It'll create an output template that points to the location in S3 where that code was uploaded. So now you have this sort of canonical template that defines an exact version of your code to be deployed, and you can now take this generated template and deploy it multiple times and ensure that you're always going to get the exact same version of your code deployed to each environment. So the second piece of the SAM system is the transform that actually lives inside of AWS CloudFormation. So what happens is the output template that we saw the SAM CLI create gets pushed to CloudFormation. However, inside of that template, you still have things like AWS Serverless function resource types, which CloudFormation doesn't natively understand. And to a certain extent, those types of resources are really higher level kind of abstract concepts that really represent multiple things under the covers. So the SAM transform, what it's responsible for doing is taking those serverless resource types and converting them into native CloudFormation resources. So a serverless function itself may be converted into a Lambda function, as well as an IAM role, as well as any other implied resources that get generated as a result of the event mappings that you create. So this allows you to essentially manage your application entirely within the native CloudFormation constructs that you already know and love. So you still have access to all of the same features that you do for managing CloudFormation stacks when you're using SAM. And all of the kind of translation and transformation between the SAM template concepts and the CloudFormation resource types gets handled for you automatically. This also means that you can embed any kind of native CloudFormation resource into a SAM template as well. So if you want to mix and match serverless and non-serverless components, that's entirely possible, and in fact very much encouraged for you to sort of manage all of the various pieces of your application, even if you've got kind of a mix of both serverless and non-serverless components. So now if we go back and take a look at sort of what does it look like to do that deployment again. So moving from this kind of 10-step process, we can now convert that using SAM into a very simple 2-step process where we simply do a SAM package and a SAM deploy using the CLI, and under the covers it will kind of take care of actually deploying and creating all of these resources for us with using CloudFormation. So again, the bottom line here is just, anytime you're building serverless applications, it's definitely a good idea to invest in the automation and invest in repeatable, standardized deployments. And using SAM gives you a lot of advantages in terms of just the overall concision that you can use to author templates, makes them more understandable and easier to maintain, and gives you a really kind of easy way to manage deployments into multiple environments. I think it's important to note, especially within the context of a partner event, that SAM is not the only option here when it comes to building serverless applications and having a defined application model. There are a number of different open source options, as well as other partners that we have that have similar offerings that in some cases completely replace the need to use SAM, in other cases integrate with SAM and provide you with additional kind of value add tooling on top of the SAM platform itself in order to build those. And so it's not so important that you use SAM specifically. I think the real key here is from a developer perspective, and when it comes to really kind of building on top of the tool set that you need in order to be successful with serverless, it's you definitely need to have some kind of deployment automation framework that you're using. So whether that's AWS SAM or using something like the serverless framework or Stackery or Pulumi or any of these other tools that exist out there, pick one, I think, is really the core kind of advice that we have here. Now, we've talked a little bit about kind of how to automate the deployment of an individual stack, but I think it's also important to talk a little bit about how to manage environments and how those environments map to various AWS accounts. So unlike in a server-based architecture where kind of a VPC tends to be a unit of isolation that's commonly used to divide multiple different environments, now there oftentimes isn't this concept of a VPC that you're integrating with. And instead, the actual CloudFormation stack itself becomes kind of the container that your application lives inside of. And so as a result of that, you have a couple of different options when it comes to how you manage environments for individual developers. So developers definitely should have the ability to deploy the version of the code that they're currently working on into a real live AWS account. I think it's definitely important that they have the ability to quickly iterate on code and see what it actually looks like when you run it inside of a real AWS account, as opposed to just kind of running things locally. And so in order to achieve that, there's a couple of different options. So the first is to provide every developer with their own sandbox account, which I think is definitely has a lot of advantages in terms of just keeping everyone isolated from one another. You don't have to worry about stepping on each other's toes or accidentally deleting resources out from under another developer. And typically, this is the approach that I would recommend to customers, assuming that they have the automation in place to be able to manage accounts at scale. So depending on the maturity level of a particular customer within the context of their journey to the cloud, different customers have varying abilities to provision and manage accounts. And for some customers, that can be challenging given their own kind of internal security and governance requirements, and the ability to set up CloudTrail and monitor those things and provision cross-account roles for management and hook into their internal identity providers and things like that. Assuming that they've got the automation in place to help manage that, and they've got a good strategy for how to manage AWS accounts at scale, definitely, if you can, provision a separate account or at least a set of accounts that the development team can kind of all use and keep each other sort of isolated from that perspective. If that's not realistic, if creating completely isolated accounts is just too sort of labor intensive for the security team, for instance, using a shared sandbox is certainly a viable option as well. So as long as you're designing your SAM templates well and not hard coding, physical resource names and things like that, there's no reason that you can't deploy the same SAM template multiple times inside of the same account and have multiple different stacks representing different versions of that same application. So you can certainly have developers and other non-prod environments share the same AWS account and simply use the stack construct in order to manage that. So that's certainly a viable option as well. However, again, you just have to be careful that you don't have any naming collisions, as well as make sure that that people are being thoughtful in terms of how they manage and delete and update various environments in those types of scenarios. So this applies as well to kind of the CI/CD automation that customers build. So when it comes to actually building these pipelines, I think the key thing to understand here is that, again, you're using very much the same kind of tool set that you typically would in a traditional application development scenario, in terms of the tools that you're actually using to manage the pipeline itself, as well as any build tools and test tools specifically. you would continue to use the same things, and then it's really just the deployment phases specifically that you would use a serverless specific tool like SAM to kind of manage deployments. And then, again, this is a relatively standard kind of guidance that we would advise even in non-serverless kind of applications. However, I think it's particularly important when you move to serverless is to make sure that you have account segregation between your production and non-production accounts. So we talked in the last slide about having kind of a shared sandbox account and potentially having multiple developers all using one kind of shared account for non-production usages and for kind of a development sandbox environment. However, that is definitely not advised when it comes to your actual production environments. So typically you would want to have a completely segregated production account that has limited access to only the individuals that really need to have access to that account, and segregate that from the rest of your environments, at least using one other non-production account, if not a number of other sandbox and non-product accounts. So as we talked a little bit, I jumped the gun, I think, on this piece where talking about kind of some of the other options besides just using AWS SAM. The number of different open source options that I've kind of listed out here that you can take a look at. Each one of them kind of has a slightly different spin on things and different take on how to help manage the organization and deployment of your serverless application. But again, the point here is really make sure that you're using a tool. Hand rolling your own automation on top of something like AWS CLI, writing a bunch of Python scripts yourself is almost never a good idea. There's been a lot of work put into all of these various different tools, and many of them are extremely mature at this point. And typically, I have not seen any customers be terribly successful in kind of building their own compared to the ones who've chosen to use a more established, mature tool that's already out there. So now that we've talked a little bit about kind of the deployment piece of managing serverless applications, I wanted to talk also about kind of the testing part. So this is definitely an area where we get a lot of questions from developers, and I think there's a lot of kind of misunderstanding around what the right way to sort of approach testing is in the serverless world. So I think, again, what's really important to think about when we talk about testing is this idea of having kind of a holistic testing strategy. So there's more than just one type of test that you want to kind of think about. So first of all, you need some sort of strategy for testing locally. So very kind of quick turnaround, fast feedback loop where as a developer, I'm writing some code and then immediately kind of testing it to see if it's working. Ideally, I'm automating those using some sort of unit testing framework, and then also potentially doing more exploratory testing in my local environment as well. But some sort of strategy for developers to kind of manage that locally. You also want to have kind of a remote integration test type of option where you can deploy a full service into an AWS or production-like environment, and then run remote tests against that API or against that service to test kind of at an integration level what's going on. And then last is kind of integrating those integration tests, or automating those integration tests as part of a CI/CD pipeline, and making sure that that's included as part of the kind of gates to get you through the various application environments that you're deploying. So looking at kind of local testing, I think that's really the area that most people have questions about. So again, the integration testing piece, and when you're doing sort of API level testing, those tools don't need to change. So whatever strategy you're using today to manage testing of APIs that are deployed on top of server-based architectures can continue to be used to test the serverless APIs that you create. And the same is true of any other kind of front-end testing tools. If you've got rich web applications that you're deploying on top of S3, etc. A lot of those styles of testing don't really need to change. But what does need to change a little bit is kind of how you manage local testing. And so I think the first piece to talk about is kind of plays into how you manage unit testing in general. And one of the key pieces I think that's important to understand about making your serverless projects testable is that you need to adhere to good sort of object-oriented, or depending on your language, functional kind of code design. So this is really about kind of decoupling the core business logic of your application or of your Lambda functions from the Lambda specific details of the execution environment. So typically when I talk to customers about managing serverless applications and writing code, usually the kind of starting point to talk about is make sure that you're dividing your code logically into these different components, where you've got kind of a handler that's responsible for managing some of the Lambda specific stuff. You've got your business logic and a controller, and then you're using separate service abstractions in order to kind of communicate with the outside world. So when you're writing a handler kind of function, basically this should be all of the code necessary to set up the configuration for your particular function. So reading in environment variables, or going out and accessing other sources of configuration that your business logic really doesn't need to be aware of. That's kind of what you want to manage there. You would also be doing anything in terms of kind of parsing Lambda event structures that are kind of specific to Lambda. So unpacking those event objects, turning them into more business-oriented objects that you can then pass down to the controller. The controller is basically where you're going to put the core business logic. So this is the meat of your function. This is where the majority of the code that you're going to write should live. Your handlers should be relatively thin. You typically aren't going to put a ton of different, a ton of code into those. They should be relatively thin and fairly static as well. You shouldn't have to change them very often. And so as a result, you can sort of test those independently of the business logic that actually lives inside of your controller. And the idea here is to write code in such a way that this is now completely platform agnostic. So if you wanted to, instead of using the Lambda handler wrapper, create a separate kind of wrapper component that would integrate with, a standard web application framework within, of your language. So if you're writing a Java application, something that could provide like integration with a servlet container, for instance, the controller class wouldn't need to change at all. It's simply receiving requests and providing back responses using these kind of business objects that are completely decoupled from the actual platform that it's being hosted on. And then the last kind of piece would be kind of a services layer that would be responsible for any external integrations and abstracting away, again, any of the kind of implementation details of how you communicate with those external services, whether those be hosted cloud services or other APIs that you've written yourself. So one of the reasons that this is such a powerful paradigm, and one of the reasons it's important to continue to do this. So again, I don't think that this particular practice of dividing your code into logical units like this is anything that's new to people that are seasoned in software development practices. But oftentimes, I think when people move into Lambda functions, they start thinking about functions as being these really simple, small things. And so I can just throw all of my code into my handler function directly, and kind of building this out into an actual layered architecture that has some that actually builds out these independent decoupled components is sometimes something that people miss, I think, when they're kind of moving into the serverless world. And so one of the big benefits, though, that you get when you do this is that now you've got all of the actual interesting business logic that you really want to test isolated in a way that you can start writing automated tests against that without needing to know anything about the Lambda runtime. So your automated tests don't have to go and try and completely mock out the Lambda execution environment, you can make calls directly into these sort of business methods that your controller exposes and test them that way in isolation without having your tests need to be concerned with the platform that you're actually running on, which I think is definitely a good practice to work towards. Now, we've talked a little bit about sort of the front end of how your tests would integrate with your business logic layer, but there's still kind of that back end piece, the services on the back end that your controller is dependent upon, that it needs to be able to interact with on the back end. And so when we're talking about kind of isolated unit tests, or even other just automated tests that are intended to be run locally, the topic of mocking comes up a lot, and like, how do we deal with services like DynamoDB or Kinesis or something like that maybe are only available in the cloud and not something that you necessarily have a version of running on your local machine. So there's a few options in terms of how you can kind of address this. The first is using something like DynamoDB Local or Local Stack. So DynamoDB Local is a project that AWS publishes that provides you with a local implementation of the DynamoDB API, to where you can write tests, you can write records, read them back, query a database the same way that you would in the cloud, and provides you with a way to build kind of a local testing environment that mimics the exact API that the DynamoDB service itself provides. And then Local Stack is an open source project that attempts to do similar types of a similar mock platform for a number of other AWS services like SQS and SNS, and there's a number of other ones that are included in that project. So using, and again, whether it's using these specific projects to build this out, or other ones that are available, or building kind of your own implementations to stub out some of the functionality, you could certainly kind of do that in order to get a localized version of the various other external services that you're using. The other option is to kind of build out custom mocks. So this is where inside of your actual inside of the execution process itself, where your tests are running, you would mock out the functionality for various services like a DynamoDB table or a Kinesis stream, so that you can actually pass data between multiple Lambda functions and see all of your Lambda functions working in concert with one another. Now, this is a pretty expensive kind of route to take. We don't have a lot of customers that end up doing this, but the ones that have done it definitely see a lot of value in it. It is something that gives you the ability to debug very interesting distributed problems where you've got multiple Lambda functions that are all reading and writing from similar data sources, and you introduce interesting race conditions and other kind of asynchronous cases. And in those cases, sometimes it can be really valuable to kind of have this custom mocking framework that allows you to single step through kind of how all of these different pieces are relating together. Because by default, even with something like DynamoDB Local, or even using the real DynamoDB, you're not going to have the ability to have sort of two functions that are running locally on your development environment kind of communicate with one another through one of those services today. So if that's an important piece of functionality that you really want to have test coverage for, then this is one of the ways that you can kind of achieve that. And then the final option for mocking is don't. And really, I think this is the one that I typically encourage customers to start with. In 2018, doing software development without an internet connection, I don't think is particularly realistic. I think for a number of different reasons, we live in a connected world, and most of the tooling that we use as software developers is highly dependent upon having an internet connection. And so, using a real live DynamoDB table that you connect to that's running in the cloud, and you connect to that from your local environment in order to run tests against, I don't think is a bad approach at all. And in fact, it's got a lot of benefits in terms of being very low cost from a development perspective, because you're not having to build or maintain any of the components in order to build out that mock, and you're sort of guaranteed that you've got high fidelity with the actual production APIs that you're going to be using, because you're actually using the real APIs themselves. So you never have to worry about any of your mocks drifting from the actual kind of real contracts of the APIs that you're trying to mock out. So in most cases, this is what I would recommend customers start with, and then if you have good reasons that you need to kind of move to one of the other mocking strategies, then you can kind of evaluate that on a case-by-case basis. So the last kind of concept that I wanted to touch on is debugging. So we've talked about how you can approach kind of testing from a local perspective, both in terms of writing automated unit tests and mocking out your backend. But then the kind of debugging process is definitely one that I think is challenging for a lot of developers when they first start serverless development, because there's sort of a fundamental difference between AWS Lambda and other deployment platforms. Namely, there is a great feature of pretty much every modern language runtime that allows you to open up a port on a running process that allows you to connect a remote debugger to that process. However, when you deploy your code to a Lambda function, this is no longer possible. So Lambda itself, part of its security model, doesn't allow you to actually listen on additional ports. So even if you were to start a process inside of the Lambda execution context that was listening on a debug port, the Lambda service itself would block any inbound traffic that tried to connect to that. And so this whole model of being able to kind of run code remotely and then connect to it with a debugger is problematic when you're trying to do this in sort of the real kind of deployed Lambda function environment. However, going back to the SAM CLI that we talked about previously, SAM provides you with a mechanism where you can actually run your code locally inside of a simulated Lambda execution environment that utilizes Docker to simulate kind of the SAM service itself, and then by virtue of the fact that you're now running this process locally, you can connect a remote debugger to it. And that provides you with this ability now to connect your local IDE to this, an instance of your Lambda function that's actually executing locally, and use all of the same kind of single step debugging tools that you're used to, and then edit code, make changes, and then immediately kind of see how those changes look inside of your local environment. So I think that this diagram gets a little bit kind of busy, and it's probably easiest if we just take a look at an actual kind of live demo of this. So I'm going to switch over right now to my IDE here, which is a VS Code instance where I've already got a serverless application kind of built. So this is just a really simple dummy API with a simple web application front end written with React. The API itself is really simple. It's just got a single method on it that you can request a greeting, and it will respond back with hello name. So pretty straightforward. And again, this is kind of the template where I'm defining this hello world function and defining kind of the API. So when you post to /hello, it should respond back to you with hello and your name. So with that being said, what we can do is I can start up the React kind of test server. So again, this is nothing kind of serverless specific. I just happen to build the front end of this using React, and that's going to bounce me over to my browser, and I'll be able to hopefully see the my local version of this web application here. So again, just really super simple kind of HTML based application with some JavaScript on the back end where you can enter a name and then ask for it to greet you. But right now nothing's going to happen because the backend API that I have is broken. So you'll see an error here that it was trying to proxy to my actual API, but that's not running yet because I haven't started the SAM CLI. So let's take a look at this API component. So the API component is what would actually be deployed to our AWS environment in kind of a production sense. This API project is what is defined with this template here. So here I'm going to come and use the SAM CLI to start a local version of this API. And so to do that, I'll just type SAM local start API. So this is, again, going to start a local version of my API that exposes a /hello resource that I can post to. So now if I come back over here and click the button again to greet me, hopefully, yeah, it'll respond back and I get this hello undefined. So obviously I've got a bug in my service at this point, but at least I'm getting kind of that communication back and forth between my web application, again, that I'm running locally in my browser, and the local version of the API that I've got running through SAM CLI. So the next kind of step here is to go and kind of figure out what's wrong. So, you know, this is the handler function. There's not a lot going on here, but I want to go ahead and debug this process here so I can maybe figure out exactly what's going wrong and why I'm getting that undefined. So I'm going to go ahead and stop my my current kind of API and start it again using debug mode. So I'm gonna pass in the debug flag with a port, and that's going to again start the same process, but using a local container that's listening on this port for a debugger to connect. So now I can come back here, run my API request again, and now go ahead and attach to this SAM local debug instance that I've configured previously. And there's nothing too fancy about what I had already configured. It's really just setting up that 5858 port in the debug configuration for Visual Studio Code. And now we're in our interactive debugger. So by default, it's going to drop me into kind of the core SAM CLI, you know, code. But I've already got my breakpoint set here, so I can just go ahead and play through all of that to get to, okay, my actual function code. So now I see here where I'm calling back. I can see the response body. If I hover over this, and sure enough, I'm getting message hello undefined. I could take a look at where, you know, messages being defined and look and see what's going on here with body. Oh, sure enough, body has this name parameter, but it's a lowercase name, whereas I'm trying to pull up uppercase name. So that should be an easy enough fix. We can change that and save it. We can let this execution continue through, but that's obviously still going to have the undefined process. So I can go ahead and restart my API. I'm not going to debug it this time. I'm going to go ahead and just start the API directly. And now we've kind of updated the code, and so I should be able to come back and again, one more time, call greet me, and sure enough, now I get the correct behavior that I was looking for. I can try it with, you know, a different name, and see that in fact I'm getting real responses. Maybe there's a little bit of a, yeah. So there's a little bit of kind of additional latency in kind of how the SAM CLI is spinning up a Docker container under the covers in order to handle this. But overall, you get a really kind of quick feedback loop that you can develop without having to go through kind of a full remote deployment process. And another great feature of this is if I want to go and actually make changes to my application code. So I'm just going to make a really trivial change, but something to demonstrate that, you know, there's been an update made. I just saved the file. I didn't actually redeploy anything. I didn't have to go and restart my SAM CLI process. And I can come back here, click again, interact with that API, and I should see my updates directly. So again, kind of working through this this process to improve the feedback latency that you get as a developer. SAM CLI provides a lot of great tools to kind of help solve that problem. So that's everything that we've got for this session. Really appreciate everyone's time, and look forward to speaking to you again in the future.